There are two main classifications of machine learning, supervised and unsupervised learning. To put it simply, supervised learning uses labeled data, while unsupervised learning uses unlabeled data. What does that mean? If you're looking for a quick answer, supervised learning involves training a model on a labeled dataset where the input data is paired with a corresponding correct output, like predicting house prices. The model learns to map the inputs to the outputs by minimizing error. Unsupervised learning, on the other hand, deals with unlabeled data. So the model identifies patterns, structures, relationships within the data, such as if you're clustering similar data points. To go into more depth, we're going to go through a couple examples, starting with supervised learning. So let's take an example where we are trying to predict the price of houses. We have data on houses, whether it be their square footage, number of bedrooms, along with their corresponding prices. So because this is supervised, we know the price of these houses. And if we're trying to predict the price of a house with different data, based on we know the bedrooms and the square footage, but we don't know the price of it. So what we're going to do is use that data in this labeled supervised learning to predict the price of this house. This is supervised learning. Specifically, this is a regression task because our price is continuous. So now we can take a look at an unsupervised learning example. Let's say we have customer data. Within this data, we have the shopping habits of the customers. So let's say this shopper purchases art and groceries. This customer purchased electronics and furniture. And this customer purchases groceries and snacks. In an unsupervised learning, if our goal here is to group these customers based on the data we have, a clustering model may be used to group, let's say, customer 1 and 2 based on their shared data of purchasing groceries. This is just a simple example, but in this scenario, we do not have pre-designated groupings for the customers, which is what makes this an unsupervised learning example. And we'll provide a list of a few examples of usages for supervised versus unsupervised learning. One common usage of supervised learning is regression, which is the example we looked at earlier, where we were trying to predict a continuous variable. Another example is classification. That would be a similar example where we would be predicting a non-continuous variable, or a class. In both of these scenarios, we have known target variables that we are trying to predict, and we have example data or training data where we have known values for those target variables associated with data points. An example of unsupervised learning is clustering. That's what we looked at with the customer data, where we're trying to create groups based on data that we have, but we don't have predefined predictive labels. Another example is dimensionality reduction, where you're trying to reduce the dimensions of your data, or number of features or columns. In another video, we'll be going into more depth within each one of these, so feel free to check those out if you're interested in learning more about these specific types of supervised and unsupervised learning. But overall, to sum up what we've talked about, supervised learning uses labeled data where we come into the problem knowing a target variable that we are trying to predict, and we have examples with known values for that target variable. With unsupervised learning, we do not have a designated target variable. We just have rows of data that we are trying to, whether it be to group them into clusters or reduce the dimensions of the data. We have no known labels for those data points. Thank you for watching, and feel free to check out the next video where we go into more depth about these machine learning topics, or take a look at the channel in general and see if there's anything that piques your interest.